So in physics, it's always good to have an intuitive idea of what you might expect. And when you conduct an experiment, you're often testing your hypothesis, checking your intuition. And so when results don't match up with what you expect at all, that's when surprising things happen. And that's where greater insight is learned. One of the things that's always interesting is for any experimental work, nature almost always tells us the right answer. And so we can test things. And I have just a short plastic tube. I've got two identical balloons. As you can see, I've blown one up a lot, blown the second balloon up just a tiny bit. I've attached them to the tube. I've twisted this balloon to make sure the air can't yet exchange places. So as I untwist this, what do we think happens? Most people look at this, and essentially everybody really knows the answer. It should equilibrate, should perhaps equalize the pressure. We'll see what happens. So as this untwists and air exchanges, and it happens every time. So the small balloon gets smaller, the big balloon gets bigger. When I test this in front of our students, whether they're undergraduates in my third year stellar physics class or people coming for interview days or the public, most people guess the other way. The small balloon gets larger, the big balloon gets smaller until it's equal volume. And that would equilibrate pressure. However, these are elastic balloons and it's fairly complicated, but the simplest way to think about this is that there's a curvature. The small balloon, if you were to measure, for example, a centimeter, has more curvature than the larger balloon. And that curvature adds inward pressure. It pulls more inward for that same length. And so there's greater pressure. And you know that because it's actually harder to start the balloon inflating. And that, to a good first order approximation, is down to just essentially the curvature of the balloon.